we will study the chapter 1, that is software and software engineering. He had the classic look of a senior executive for a major software company, mid 40s, slightly graying at the temples, trim and athletic, with eyes that penetrated the listener as he spoke. But what he said shocked me. Software is dead. अरे बाप रे, ये क्या बोल दिया? Software is dead. I blinked with surprise and then smiled. You are joking, right? The world is driven by software and your company has profited handsomely because of it. It isn't dead, it's alive and growing. He shook his head empathy, em- emphatically. Emphatically. No, it's dead, at least as we once knew it. I leaned forward. Go on. I leaned forward. Go on. He spoke while tapping at the table for emphasis. The old school views of software, you buy it, you own it, and it's your job to manage it, that's coming to an end. Today, with Web 2.0 and pervasive computing coming on strong, we are going to be seeing a completely different generation of software. It will be delivered via the internet and will look exactly like it's residing on each user's computing device, but it will reside on a faraway server. अनावश्यक कहानियों पे ध्यान मत दो, मेन बात पे ध्यान दो। ये बस ये समझाने के लिए क्या है कि पहले के ज़माने में सॉफ्टवेयर जैसे था वैसा नहीं है, अब सॉफ्टवेयर डेड भी होता है। तो मेन बात है, ये कहानी नहीं वहाँ पे जाके लिखना है। एग्ज़ाम में एक कहानी नहीं लिखना है, मेन बात लिखना है कि सॉफ्टवेयर डेड भी होता है। क्यों? अब एक क्विक लुक लेते हैं। What is it? Computer software is the product that software professionals build and then support over the long term. It encompasses programs that execute within a computer of any size and architecture, content that is presented as the computer programs execute, and descriptive information in both hard copy and virtual forms that encompasses virtually any electronic media. Software engineering encompasses a process, a collection of methods, practice, and an array of tools that allow professionals to build high quality computer software. Who does it? Software engineers build and support software, and virtually everyone in the industrialized world uses it either directly or indirectly. Why is it important? Software is important because it affects nearly every aspect of our lives and has become pervasive in our commerce, our culture, and our everyday activities. Software engineering is important because it enables us to build complex systems in a timely manner and with high quality. अगर मैं इस स्पीड पे काम करूँ ना, केवल इंग्लिश में तुम्हें पढ़ के रीड करके दे रहा हूँ और तुम्हें सब समझ में आ रहा है, तो मैं तो NPTEL बहुत जल्दी ख़त्म कर दूँगा। इस वीक में ही पूरा का पूरा NPTEL ख़त्म करो, अगर तुम इस स्पीड पे समझ रहे हो। अगर मुझे फिर इसी चीज़ को हिंदी में तोड़ के बताना होगा एक एक लाइन को, दैट टेक्स टाइम। तो एक एक लाइन को मत बताओ, इंग्लिश पढ़ते पढ़ते जो मेन 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 मुद्दा जो तुम्हें आया ना हिंदी में, मेन मुद्दा जो आया ना हिंदी में जो तुम्हें मेन मुद्दा नज़र आए, मेन मुद्दा जो नज़र आए तुम्हें हिंदी में, वो बता दो तुम हिंदी में। बाकी तो तुम पढ़ लो, कहानी है तो कहानी को इंग्लिश में पढ़ो, हर एक लाइन को नहीं तोड़ तोड़ के बताना हिंदी में, उसका कोई मतलब नहीं रहेगा। हमें जल्दी ख़त्म करना है ना NPTEL पे, और सब कुछ हमें जल्दी ख़त्म करना है। 20,000 करोड़ की कंपनी चाहिए हमें। Software engineering is important because it enables us to build complex systems in a timely manner and with high quality. What are the steps? You build computer software like you build any successful product, by applying an agile, adaptable process that leads to a high quality result that meets the needs of the people who will use the product. You apply a software engineering approach. What is the work product? From the point of view of a software engineer, the work product is the set of programs, content, data, and other work products that are computer software. But from the user's viewpoint, the work product is the resultant information that somehow makes the user's world better. ठीक है, but from the user viewpoint, But from the user's viewpoint, the work product is the resultant information that somehow makes the user's world better. How do I ensure that I have done it right? Read the remainder of this book. Select those ideas that are applicable to the software that you built and apply them to your work. I had to agree. So your life will be much simpler. You guys won't have to worry about five different versions of the same app in use across tens of thousands of users. He smiled. Absolutely. Only the most current version residing on your servers. On our servers, when we make a change or a correction, we apply updated functionality and content to every user. Everyone has it instantly. I grimaced, but I grimaced. But if you make a mistake, everyone has that instantly as well. He chuckled. True. That's why we are redoubling our efforts to do even better software engineering. Problem is, we have to do it fast because the market has accelerated in every application area. I leaned back and put my hands behind my head. You know what they say? You can have it fast, you can have it right, and you can have it cheap. Pick two. Arey baap re baap. You can have it fast, you can have it right. Yeah, fast, yes, or fast, right, and cheap. Pick only two. Fast, cheap. Acha, it will. I will take it fast and right, he said as he began to get up. I stood as well. Then you really do need software engineering. I know that, he said, and he began to move away. The problem is, we have got to convince still another generation of techies that it's true. Is software really dead? If it was, you wouldn't be reading this book. Computer software continues to be the single most important technology on the world stage, as it's also a prime example of the law of unintended consequences. 50 years ago, no one could have predicted that software would become an indispensable technology for business, science, and engineering. That software would enable the creation of new technologies, for example, genetic engineer and nanotechnology, the extension of existing technologies, telecommunication, and the radical change in older technology. 50 years ago, no one could have predicted that software would become an indispensable technology for business, science, and engineering. That, that software would enable the creation of new technologies, that is genetic engineering and nanotechnology. Wow. The extension of existing technologies, for example, telecommunications, and the radical change in older technologies, that is the printing industry. That software would be the be the driving force behind the personal computer revolution. That shrink wrapped software products would be purchased by consumers in neighborhood malls. That software would slowly evolve from a product to a service as on-demand software companies delivered just-in-time functionality via a web server. That a software company would become larger and more influential than almost all industrial era companies, and that a vast software driven network called the internet would evolve and change everything from library research to consumer shopping to political discourse to the dating habits of young baap re baap and not so young adults. No one could foresee that software would become embedded in systems and all kinds: transportation, medical, telecommunication, military, industrial, entertainment, office machines. The list is almost endless. And if you believe the law of unintended consequences, there are many effects that we cannot yet predict. No one could predict the millions of computer programs would have to be corrected, adapted, and enhanced as time passes. The burden of performing these maintenance activities would absorb more people and more resources than all work applied to the creation of new software. As software's importance has grown, the software community has continually attempted to develop technologies that will make it easier, faster, and less expensive to build and maintain high quality computer programs. Some of these technologies are targeted at a specific application domain, for example, website design and implementation, Others focus on a technology domain, for example object oriented systems or aspect oriented system programming. And still others are broad based, for example operating systems such as Linux. However, we have yet to develop a software technology that does it all, and the likelihood of one arising in the future is small. And yet people bet their jobs, their comforts, their safety, their entertainment, their decision, and their very lives on computer software. It better be right. This book presents a framework that can be used by those who build computer software, people who must get it right. The framework encompasses a process, a set of methods, and an array of tools that we call software engineering. Okay, the nature of software. Okay, ये क्या है वोट ideas and technologies discoveries Ideas and technological discoveries are the driving engines of economic growth. Wall Street Journal. Acha. Ideas and technological discoveries are the driving engines of economic growth. Wall Street Journal. सही बोला. Ideas and technological discoveries are the driving engines of economic growth. The nature of software. Today, software takes on a dual role. It is a product and at the same time the vehicle for delivering a product. As a product, it delivers the computing potential embodied by computer hardware, or more broadly by a network of computers that are accessible by local hardware. Whether it resides within a mobile phone or operates inside a mainframe computer, software is an information transformer producing, managing, acquiring, modifying, displaying, or transmitting information that can be as simple as a single bit or as complex as a multimedia presentation derived from data acquired from dozens of independent sources. As the vehicle used to deliver the product, software acts as the basis for the control of the computer operating systems, the communication of information networks, and the creation and control of other programs, software tools, and environments. Software is both a product and a vehicle that delivers a product. Acha. Software is both a product and a vehicle that delivers a product. And creation and control of other program, software tools and environment. Software delivers the most important product of our time, information. It transforms personal data, for example an individual's financial transactions, so that the data can be more useful in a local context. It manages business information to enhance competitiveness. It provides a gateway to worldwide information network, for example the internet, and provides the means for acquiring information in all of its forms. The role of computer software has undergone significant change over the last half century. Dramatic improvements in hardware performance, profound changes in computing architecture, vast increases in memory and storage capacity, and a wide variety of exotic input and output options have all predicted more sophisticated and complex computer based systems. Sophistication and complexity can produce dazzling results when a system succeeds, but they can also pose huge problems for those who must build complex systems. Today, a huge software industry has become a dominant factor in the economies of the industrialized world. Teams of software specialists, each focusing on one part of the technology required to deliver a complex application, have replaced the lone programmer of an earlier era. And yet the questions that were asked for the lone programmer are the same questions that are asked when modern computer based systems are built. Why does it take so long to get software finished? Why are development costs so high? Why can't we find all errors before we give the software to our customers? Why do we spend so much time and effort maintaining existing programs? Why do we continue to have difficulty in measuring progress as software is being developed and maintained? These and many other questions are a manifestation of concern about software and the manner in which it is developed, a concern that has led to the adoption of software engineering practice. Software is a place where dreams are planted and nightmares harvested, and an abstract mystical swamp where terrible demons compete with panaceas magical panaceas, a world of werewolves and silver bullets. Brad Jacobs. Compete with magical panaceas, a world of werewolves and silver bullets. Werewolves and silver bullets. Brad J. Cox. These and many other questions are a manifestation of the concern about software and the manner in which it is developed. A concern that has led to the adoption of software engineering practice. Defining software. Today, most professionals and many members of the public at large feel that they understand software, but do they? A software description of A textbook description of software might take the following form. Software is instructions, computer programs that, when executed, provide desired features, functions, and performance. Second point, data structures that enable the programs to adequately manipulate information. And third point, descriptive information in both hard copy and virtual forms that describes the operation and the use of the programs. There is no question that other more complete there is no question that other more complete definitions could be offered, but a more formal definition probably won't measurably improve your understanding. More formal definition probably won't measurably improve your understanding. To accomplish that, it's important to examine the characteristics of software that make it different from other things that a human being build. Software is a logical rather than a physical system element. Therefore, software has characteristics that are considerably different than those of hardware. Software is developed or engineered. It is not manufactured in the classical sense. Although some similarities exist between software development and hardware manufacturing, the two activities are fundamentally different. In both activities, high quality is achieved through good design, but the manufacturing phase for hardware can introduce quality problems that are non existent. Software is engineered, not manufactured. In an excellent book of essays on the software business, Tom DeMarco, DEM 95, argues that counterpart, that counterpoint. He states, instead of asking why software costs so much, we need to begin asking what have we done to make it possible for today's software to cost so little. The answer to that question will help us continue the extraordinary level of achievement that has always distinguished the software industry. Now let's see the failure curve for hardware. Now let's see the failure curve for hardware. This is the failure rate and time. Failure rate versus time. First, it is decreasing infant mortality. देख रहे हो यू शेप्ड ग्राफ है. इन्फेंट मॉर्टेलिटी और फिर टाइम के साथ फिर मतलब शुरुआत में भी उसका जो है सो टाइम फेलियर रेट ज़्यादा है, फिर फेलियर रेट कम हो जाता है, फिर बाद में फेलियर रेट बढ़ जाता है. तो पहले जो फेलियर रेट बढ़ा हुआ था उसको बोलते हैं इन्फेंट मॉर्टेलिटी, और बाद में जो फेलियर रेट बढ़ गया उसको बोलते हैं वीयर ऑट. ठीक है, वीयर आउट. एक शुरू में जो बढ़ा हुआ है उसका फेलियर रेट वर्सेस टाइम है. तो स्टार्टिंग में जो बढ़ा हुआ है फेलियर रेट वो है इन्फेंट मॉर्टेलिटी, और बाद में जो फेलियर रेट बढ़ा हुआ है वो है वीयर आउट. ओके. In both activities, high quality is achieved through good design, but the manufacturing phase for hardware can introduce quality problems that are non-existent for or easily corrected for software. Both activities are dependent on people, but the relationship between people applied and work accomplished is entirely different. See chapter 24. Okay, both activities require the construction of a product, but the approaches are different. Software costs are concentrated in engineering. This means that software projects cannot be managed as if they were manufacturing projects. Software is engineered, not manufactured. Software doesn't wear out, but it does deteriorate. But it does deteriorate. सॉफ्टवेयर वियर आउट नहीं करता, लेकिन वो डेटीरियोरेट होता है. डेटीरियोरेट होता है. ठीक है ना. फेलियर कर्व फॉर हार्डवेयर. अच्छा, वो हार्डवेयर का था फेलियर कर्व. वो जो मैंने फेलियर कर्व बोला ना, वो हार्डवेयर का फेलियर कर्व था. फेलियर रेट वर्सेस टाइम. वो हार्डवेयर का फेलियर रेट था कि इन्फेंट मॉर्टेलिटी और फिर वियर आउट. सॉफ्टवेयर वियर आउट नहीं करता. सॉफ्टवेयर जो है सो डेटीरियोरेट करता है. सॉफ्टवेयर वियर आउट नहीं करता, सॉफ्टवेयर डेटीरियोरेट करता है. हार्डवेयर वियर आउट करता है. फेलियर कर्व फॉर हार्डवेयर होता है इन्फेंट मॉर्टेलिटी और फिर वो वियर आउट. सॉफ्टवेयर का फेलियर रेट ऐसे नहीं होगा. वो हार्डवेयर का फेलियर रेट है इन्फेंट मॉर्टेलिटी और वियर आउट. Software doesn't wear out. Figure 1.1 depicts failure rate as a function of time for hardware. Figure 1.1 depicts failure rate as a function of time for hardware. The relationship often called the bathtub curve. इसको बोलते हैं bathtub curve. The relationship, often called the bathtub curve, indicates that hardware exhibits relatively high failure rate early in its life. These failures are often attributable to design or manufacturing defects. Defects are corrected and the failure rate drops to a steady state level, hopefully quite low, for some period of time. As time passes, however, the failure rate rises again as hardware components suffer from the cumulative effects of dust, vibration, abuse, temperature extremes, and many other environmental maladies. Stated simply, the hardware begins to wear out. Software is not susceptible to the environmental maladies that cause hardware to wear out. In theory, therefore, the failure rate curve for software should take the form of the idealized curve shown in figure 1.2. It should take the curve as idealized curve shown in figure 1.2. Undiscovered defects will cause a high failure rate early in the life of a program. Undiscovered defects will cause high failure rates early in the life of a program. However, these are corrected and the curve flattens as shown. The idealized curve is a gross oversimplification of actual failure models for software. However, the implication is clear. Software doesn't wear out, but it does deteriorate. फेलियर कर्व्स फॉर सॉफ्टवेयर का ये तो आइडियलाइज्ड कर्व है, ऐसा होगा नहीं, आइडियल तो नहीं होगा। एक्चुअल कर्व ऐसा होता है, पहले फेलियर रेट ज़्यादा होता है, फिर कम होता है, और फिर ऐसे फिर वो कम हो से बढ़ता रहता है थोड़ा-थोड़ा, लेकिन बीच में स्पाइक्स आते हैं, स्पाइक्स, और फिर एक्सपोनेंशियल डिके, फिर एक स्पाइक, फिर एक्सपोनेंशियल डिके, फिर स्पाइक, फिर एक्सपोनेंशियल डिके। इंक्रीज्ड फेलियर रेट ड्यू टू साइड इफ़ेक्ट्स, ये फेलियर रेट हुए हैं साइड इफ़ेक्ट्स के कारण। इंक्रीज्ड फेलियर रेट ड्यू टू साइड इफ़ेक्ट्स, ये फेलियर रेट हुए हैं साइड इफ़ेक्ट्स के कारण, ठीक है। फेलियर रेट फॉर सॉफ्टवेयर भी देख लिया पॉइंट। सॉफ्टवेयर इंजीनियरिंग मेथड्स strive to reduce the magnitude of the spikes and the slope of the actual curve in figure 1.2, ठीक है। सॉफ्टवेयर इंजीनियरिंग मेथड्स स्ट्राइव टू रिड्यूस द मैग्नीट्यूड ऑफ द स्पाइक का इंक्रीज्ड फेलियर ड्यू टू साइड इफेक्ट जो है ना, वो स्पाइक का मैग्नीट्यूड कम करने की कोशिश करता है। सॉफ्टवेयर इंजीनियरिंग स्ट्राइव टू रिड्यूस द मैग्नीट्यूड ऑफ द स्पाइक एंड द स्लोप ऑफ द एक्चुअल कर्व का जो स्लोप है ना, जितना जल्दी वो गिर रहा है उतना जल्दी ना गिरे। strive to reduce the magnitude of the spike and the slope of the actual curve का स्लोप थोड़ा कम करना चाह रहा है बाद में, जो शुरू में तो रहेगा लेकिन बाद में उसका स्लोप थोड़ा कम करना चाह रहा है। दिस सीमिंग कॉन्ट्राडिक्शन कैन बेस्ट बी एक्सप्लेन्ड बाय कंसिडरिंग द actual curve in figure 1.2. During its life, software, in fact, from the moment that development begins and long before the first version is delivered, changes may be requested by a variety of different stakeholders. During its life, software will undergo change. Yes, as changes are made, it is likely that errors will be introduced, okay, causing the failure rate curve to spike as shown in the actual curve. Before the curve can return to the original steady state failure rate, another change is requested, causing the curve to spike again. Before the curve can return to the original steady state failure rate, another change is requested, causing the curve to spike again. Slowly, the minimum failure rate level begins to rise. The software is deteriorating due to change. Another aspect of wear illustrates the difference between hardware and software. When a hardware component wears out, it is replaced by a spare part. There are no software spare part. Every software failure indicates an error in design or in the process through which design was translated into machine executable code. Therefore, the software maintenance tasks that accommodate requests for change involve considerably more complexity than hardware maintenance. Okay. Ideas are the building blocks of ideas. Ideas are the building blocks of ideas. Jason J.P. Haji. Ideas are the building blocks of ideas. Jason J.P. Haji. Although the industry is moving towards component based construction, most software continues to be custom built. As an engineering discipline evolves, a collection of standard design components is created. Standard screws and off the shelf integrated circuits are only two of thousands of standard components that are used by mechanical and electrical engineers as they design new systems. The reusable components have been created so that the engineer can concentrate on the truly innovative elements of a design, that is the part of the design that represents something new. In the hardware world, the component reuse is a natural part of the engineering process. In the software world, it is something that has only begun to be achieved on a broad scale. A software component should be designed and implemented so that it can be reused in many different programs. Modern reusable components encapsulate both data and the processing that is applied to the data, enabling the software engineer to create new applications for reusable parts. Component based development is discussed in chapter 13. For example, today's interactive user interfaces are built with reusable components that enable the creation of graphics windows, pull down menus, and a wide variety of interaction mechanisms. So, the data structures and the processing details required to build the interface are contained within the library of reusable components for interface destruction. Web Reference, one of the most comprehensive libraries of shareware freeware, can be found at shareware.cnet.com. Library of reusable components for interface construction. ठीक है. Software application domains. Today, 7 broad categories of computer software present continuing challenges for software engineering. For software engineers, today 7 broad categories of computer software present continuing challenges for software engineers. System software, a collection of programs written to service other programs. System software, a collection of programs written to service other programs. Some system softwares, for example, compilers, editors, and file management utilities, processes. Some system software processes complex but determinate. Software is determinate if the order and timing of inputs, processing, and outputs is predictable. Software is determinate if the order and timing of inputs, processing, and outputs is predictable. Software is indeterminate if the order and timing of inputs, processing, and outputs cannot be predicted in advance. But determinate. Some system software processes complex but determinate in information structures. Other system softwares, for example, operating system components, drivers, networking software, telecommunication processors, process largely indeterminate data. In either case, the system software area is characterized by heavy interaction with computer hardware, heavy usage by multiple users, concurrent operation that requires scheduling, resource sharing, and sophisticated process management, complex data structures, and multiple external interfaces. Application software, standalone programs that solve a specific business need. Applications in this area process business or technical data in a way that facilitates business operations or management, or technical decision marking. In addition to conventional data processing applications, application software is used to control business functions in real time. For example, point of sale transaction processing, real time manufacturing process control. Engineering or scientific software has been characterized by number crunching algorithms. Applications range from astronomy to volcanology, from automotive stress analysis to space shuttle orbital dynamics, and from molecular biology to automated manufacturing. However, modern applications with the engineering scientific area are moving away from conventional numerical algorithms. Computer-aided design, system simulation, and other interactive applications have begun to take a real-time and even system software characteristics. Embedded software resides within a product or a system that is used to implement and control features and functions for the end user and for the system itself. Embedded software can perform limited and esoteric functions, that is keypad control for a microwave oven, or provide a significant function and control capability, that is, for example, digital functions in an automobile such as fuel control, dashboard displays, and braking systems. Product line software designated to provide a specific capability for use by many different customers. Product line software can focus on a limited and esoteric marketplace. For example, inventory control products or address mass consumer markets. For example, word processing, spreadsheet, computer graphics, multimedia, entertainment, database management, and personal and business financial applications. Web applications called web apps. This network centric software category spans a wide variety of applications. In their simplest form, web apps can be little more than a set of linked hypertext files that present information using text and limited graphics. However, as Web 2.0 emerges, web apps are evolving into sophisticated computing environments that not only provide standalone features, computing functions, and content to the end user, but also are integrated with corporate databases and business applications. Artificial intelligence software makes use of non-numerable algorithms to solve complex problems that are not amenable ame- amenable to computation or straightforward analysis. Applications within this area include robotics, expert systems, pattern recognition, image and voice, artificial neural networks, theorem proving, and game playing. So there were seven broad categories. First is system software, second is application software, third is engineering or scientific software, fourth is embedded software, fifth is product line software, sixth is web application, seventh is artificial intelligence software. There is no computer that has common sense. Okay, Marvin Minsky. That has there is no computer that has common sense. Marvin Minsky. Millions of software engineers worldwide are hard at work on software projects in one or more of these categories. In some cases, new systems are being built, but in many others, existing applications are being corrected, adapted, and enhanced. It is not uncommon for a young software engineer to work a program that is older than she is. Past generation of software people have left a legacy in each of the categories I have discussed. Hopefully, the legacy to be left behind by this generation will ease the burden of future software engineers, and yet new challenges. Chapter 31 has have appeared on the horizon. World Open world computing. The rapid growth of wireless technology may soon lead to true pervasive distributed computing. The challenge for software engineers will be to develop systems and application software that will allow mobile devices, personal computers, and enterprise systems to communicate across vast networks. Net sourcing. The world wide web is rapidly becoming a computing engine as well as a content provider. The challenge for software engineers is to architect simple, for example, personal financial planning and sophisticated applications that provide benefit to targeted end user markets worldwide. Open source, a growing trend that result in distribution of source code for system applications, for example, operating systems, database, and development environments, so that many people can contribute to its development. The challenges for software engineers is to build source code that is self-disruptive, but more importantly, to develop techniques that will enable both customers and developers to know what changes have been made and how those changes manifest themselves within the software. You can't always predict, but you can always prepare. Anonymous. Acha, you can't always predict, but you can always prepare. Open source, a growing trend that result in distribution of source code for system software system applications, for example, operating systems, database, and development environments, so that many people can contribute to its development. The challenge for software engineers is to build source code that is self-disruptive, but more importantly, to develop techniques that will enable both customers and developers to know what what changes have been made and how those changes manifest themselves within the software. Each of these new challenges will undoubtedly obey the law of unintended consequences and have effects for business people, software engineers, and end users that cannot be predicted today. However, software engineers can prepare by instant instantiating a process that is agile and adaptive enough to accommodate dramatic changes in technology and to business rules that are sure to come over the next decade. Legacy software. Hundreds of thousands of computer programs fall into one of the seven broad application domains discussed in the preceding subsection. Some of these are state of the art software just related to individuals, industry, and government, but other programs are older, in such cases, much older. In some cases, much older. These older programs, often referred to as legacy software, have been the focus of continuous attention and concern since 1960s. Diane Fard and his colleagues describes DAY99 ये क्या है DAY99 ये क्या लिखा रहता है describes legacy software in the following way. Legacy software systems were developed decades ago and have been continually modified to meet changes in business requirements and computing platforms. The, the proliferation of such systems is causing headaches for large organizations who find them costly to maintain and risky to evolve. Liu and his colleagues, LEU98, extend this description by noting that many legacy systems remain supportive to core business functions and are indispensable to the business. Hence, legacy software is characterized by longevity and business critically. Unfortunately, there is sometimes one additional characteristic that is present in legacy software: poor quality. Legacy systems sometimes have inextensible designs, convoluted code, poor and non existent documentation, test cases, and results. In this case, quality is judged based on modern software engineering thinking, a somewhat unfair criterion since some uh, modern software engineering concepts and principles may not have been well understood at the time and that the legacy software was developed. What do I do if I encounter a legacy system that exhibits poor quality? Okay, there were unfortunately unfortunately there is sometimes one additional characteristic that is present in legacy software: poor quality. Legacy systems sometimes have inextensible designs, convoluted code, poor or non-existent documentation, test cases, and results never achieved that were never achieved. A poorly managed change history. The list can be quite long, and yet these systems support core business functions and are indispensable to the business. What to do? The only reasonable answer may be do nothing, at least until the legacy system must undergo some significant change. If the legacy software meets the need of its users and runs reliably, if it is not broken and does not need to be fixed. However, as time passes, legacy systems often evolve for one or more of the following reasons. The software must be adapted to meet the needs of new computing environments and technology. The software must be enhanced to implement new business requirements. The software must be extended to make it interoperable with other more modern systems and databases. The software must be re-architectured to make it viable within a network environment. What type of changes are made to legacy systems? When these modes of evolution occur, the legacy system must be re-engineered. Chapter 29, so that it remains viable into the future. The goal of modern software engineering is to devise methodologies that are founded on the notion of evolution, that is, the notion that software systems continually change. New software systems are built from the old ones, and all must interoperate and cooperate with each other. Day 99. Every software engineer must recognize that change is natural. Don't try to fight it. Every software engineer must recognize that change is natural. Don't try to fight it. The unique nature of web apps. In the early days of the World Wide Web, circa ये क्या है CIRCA circa 1990 to 1995, websites consisted of little more than a set of linked hypertext files that presented information using text and limited graphics. As time passed, the augmentation of HTML by development tools, for example XML, Java, enabled web engineers to provide computing capability along with informational content. Web-based systems and applications, I refer to these collectively as web apps, were born. Today, web apps have evolved into sophisticated computing tools that not only provide a standalone function to the end user but also have been integrated with corporate database and business applications. As noted in section 1.1.2, web apps are one of a number of distinct software categories, and yet it can be argued that web apps are different. Powell Pow 98 suggested that web based systems and applications evolve a mixture between print publishing and software development, between marketing and computing, between internal communications and external relations, and between air and between art and technology. The following attributes are encountered in the vast majority of webs. पहले ये देखते हैं, ये 6 जो लिखा हुआ है, web based systems and applications. In the context of this book, the term web application, web apps encompasses everything from the simple web page that might help a customer compute an automobile lease payment to a comprehensive website that provides complete travel services for businessmen, for for business people and vacationaries. Included within the category are complete websites, specialized functionality within websites, and information processing application that reside on the internet or on the intranet or extranet. Vote. By the time we see that sort of a stabilization, by the time we see any sort of a stabilization, the web will have turned into something completely different. By the time we see any sort of a stabilization, the web will have turned into something completely different. Louis Munier. Okay. The following attributes are encountered in the vast majority of web apps. Network intensiveness. A web app resides on a network and must serve the needs of a diverse community of clients. The network may enable worldwide access and communication, for example, that is the internet, and more limited access and communication, for example, a corporate intranet. Concurrency. A large number of users may access the web apps at one time. In many cases, the patterns of users among end users will vary greatly. Unpredictable load. The number of users of the web apps may vary by orders of magnitude from day to day. 100 users may show up on Monday, 10,000 may use the system on Thursday. Performance. If a web app if performance if a web app user must wait too long if a web user must wait too long for access, for server side processing, for client side formatting and display, he or she may decide to go elsewhere. Availability. All the expectation of 100% availability is unreasonable. Users of popular web apps often demand access on a 24 slash 7 slash 365 basis. Users in Australia or Asia might demand access during a time when traditional domestic software application in North Korea might be taken offline for maintenance. Data driven. The primary function of many web apps is to use hypermedia to present text, graphics, audio, and video content to the end user. In addition, web apps are commonly used to access information that exists on databases that are not an integral part of the web based environment. For example, e commerce or financial applications. Content is sensitive. The quality and aesthetic nature of content remains an important determinant of the quality of a web app. Continuous evolution. Unlike conventional application software that evolves over a series of planned chronologically spaced releases, web applications evolve continuously. It is not unusual for some web apps, specifically their content, to be updated on a minute by minute schedule, or for content to be independently computed for each request. Immediately, all the immediately, uh, immediacy. Sorry. Content evolution. Content sensitive हो गया. The quality and aesthetic nature of content remains an important determinant of the quality of a web app. Continuous evolution हो गया. Content sensitive. The quality and aesthetic nature of content remains an important determinant of the quality of a web app. Continuous evolution. Unlike conventional application software that evolves over a series of planned chronologically spaced releases, web applications evolve continuously. It is not unusual for some web applications, web apps specifically, their content to be uploaded on a minute by minute schedule for or for content to be independently computed for each request. Immediacy. All the immediacy, the compelling need to get software to market quickly is a characteristic of many application domains. Web apps often exhibit a time to market that can be matter of a few days or weeks. In With modern tools, sophisticated web apps can be produced in only a few hours. Sophisticated web apps can be produced in only a few hours. With modern tools, sophisticated web apps can be produced in only a few hours. Immediacy. All the immediacy, the compelling need to get software to market quickly, is a characteristic of many application domains. Web apps often exhibit a time to market that can be a matter of a few days or weeks. Security. Because web apps are available via network access, it is difficult, if not impossible, it is difficult, if not impossible, to limit the population of end users who may access the application. In order to protect sensitive content and provide secure modes of data transmission, strong security measures must be implemented throughout the infrastructure that supports a web app and within the application itself. Aesthetics. An undeniable part of the appeal of a web app is its look and feel. When an application has been designed to market or sell products or ideas, aesthetics may have as much to do with success or technical design. It can be argued that other application categories discussed in section 1.1.2 can exhibit some of the attributes noted. However, web apps almost always exhibit all of them. Software engineering. In order to build software that is ready to meet the challenges of the 21st century, you must recognize a few simple realities. Software has become deeply embedded in virtually every aspects of our lives, and as a consequence, the number of people who have an interest in the features and functions provided by a specific application, I will call these people stakeholders later in this book, okay, has grown dramatically. ठीक है, specific applications has grown dramatically. When a new application or embedded system is to be built, many voices must be heard. When a new application or embedded system is to be built, many voices must be heard, and it sometimes seems that each of them has a slightly different idea of what software features and functions should be delivered. It follows that a concerted effort should be made to understand the problem before a software solution is developed. The information technology requirements demanded by individuals, businesses, and governments grow increasing complex with each passing year. Large teams of people now create computer programs that were once built by a single individual. Sophisticated software that was once implemented in a predictable self-contained computing environment is now embedded inside everything from consumer electronics to medical devices to weapon systems. The complexity of these new computer-based systems and products demands careful attention to the interactions of all system elements. It follows that design become a pivotal activity. Individuals, businesses, and governments increasingly rely on software for strategic and tactical decision making as well as day to day operations and control. If the software fails, people and major enterprises can experience anything from minor inconvenience to catastrophic failures. It follows that software should exhibit high quality. As the perceived value of a specific application grows, the likelihood is that its user base and longevity will also grow. As its user base and time in use increase, demands for adaptation and enhancement will also grow. It follows that software should be maintainable. अब कुछ पॉइंट्स हैं. पॉइंट: अंडरस्टैंड द प्रॉब्लम बिफोर यू बिल्ड अ सॉल्यूशन. अच्छा, design is a pivotal system engineering activity. Design is a pivotal system engineering. So, design is a pivotal software engineering activity. Both quality and maintainability are an outgrowth of good design. Both quality and maintainability are an outgrowth of good design. ठीक है. It follows that, ठीक है, as the perceived value of a specific application grows, the likelihood is that its user base and longevity will also grow. As its user base and time in use increase, demands for adaptation and enhancement will also grow. It follows that software should be maintainable. These simple realities lead to one conclusion: software is all of its form and across all of its application domains must be engineered. And that leads us to the topic of this book, software engineering. All the hundreds of authors have developed personal definitions of software engineering. A definition proposed by Fritz Bauer, now 69, at the seminal conference on the subject, still serves as a basis for discussion. Software engineering is software engineering is the establishment and use of sound engineering principles principles in order to obtain economically software that is reliable and works efficiently on real machines. More than a discipline or a body of knowledge, engineering is a verb, an action word, a way of approaching a problem. Scott Whitmer. Software engineering is the establishment and use of sound engineering principles in order to obtain economically software that is reliable and work efficiently on real machines. Okay, you will be tempted to add to this definition. For numerous additional definitions of software engineering, see www.answers.com /topic/software dash engineering hashtag WP dash underscore note dash 13. It says little about the technical aspects of software. You will be tempted to add to this definition. It says little about the technical aspects of software quality. It does not directly address the need of customer satisfaction or timely product delivery. Its it omits mention of the importance of measurement and metrics. It does not state the importance of an effective process. And yet Bowers, Bowers, वही फ्रिट्ज Bauer, Bauer's definition provides us with a baseline. What are the sound engineering principles? Yes, this is my question. That can be applied to computer software development. Question mark. How do we economically build software so that it is reliable? What is required to create computer programs that work effectively or not one but many different real machines? These are the questions that continue to challenge software engineers. The IEEE 993A has developed a more comprehensive definition when it states software engineering, the application of a systematic, disciplined, quantifiable approach to the development, operation, and maintenance of software. That is the application of engineering or software, the study of approaches as in one. क्या था? And yet a systematic, disciplined, and quantifiable approach applied by one software team may be burdensome to another. We need discipline, but we also need adaptability and agility. Software and engineering, more than a discipline or a body of knowledge, engineering is a verb, an action word, a way of approaching a problem. Scott Whitmer. But how do we define software engineering? Point: software engineering encompasses a process, methods for managing and engineering software and tools. Software engineering encompasses a process, methods methods for managing and engineering software and tools. And yet a systematic, disciplined, and quantifiable approach applied by one software team may be burdensome to another. We need discipline, but we also need adaptability and agility. Software engineering is a layered technology, referring to figure 1.3. Software engineering layers देखेंगे बाद में. Referring to figure 1.3, any engineering approach includes software engineering must rest on an organizational commitment to quality, total quality management, Six Sigma, and similar philosophies. Quality management and related approaches are discussed in chapter 14 and throughout part 3 of the book. सॉफ्टवेयर इंजीनियरिंग इज अच्छा, सॉफ्टवेयर इंजीनियरिंग लेयर में क्या क्या है? सबसे नीचे वाला लेयर है क्वालिटी फोकस, क्वालिटी फोकस उससे ऊपर है, उससे ऊपर वाला लेयर है प्रोसेस, उससे ऊपर वाला लेयर है मेथड, उससे ऊपर वाला लेयर है टूल्स। केवल 4 लेयर हैं सॉफ्टवेयर इंजीनियरिंग में, टूल्स, मेथड्स, प्रोसेस, क्वालिटी फोकस। नीचे सबसे नीचे वाला लेयर क्वालिटी फोकस, उससे ऊपर वाला लेयर प्रोसेस लेयर, क्वालिटी फोकस लेयर, उससे ऊपर सबसे नीचे वाला लेयर क्वालिटी फोकस लेयर, उससे ऊपर वाला प्रोसेस लेयर, उससे ऊपर मेथड्स लेयर, उससे ऊपर टूल्स लेयर।